Good evening again, and so I'm the one who doing startup this week, and I'm going to cover the manufacturing part of the robotic design. And as for the like, when you talk about robot designs, there are four main stages that are the conceptual design, mechanical design, electronic design, and the software design. So normally, yeah. So this is the normal stages that this is not only for the robot design. Any product that are developing out in the world. It is by a company or a person. These are the four main step, and conceptual design is the starting point always. And yeah, as for the mechanical, electronic, and software design, it can be different. Like we can do it parallelly, or we can do it step by step, or both, or we can do it like the. What I want to tell you is the conceptual design in the first hand, and we can do the other parts next. And when we talk about the conceptual design, the most important thing is the purpose and the functionality of your design. Like when you're designing a conceptual thing, like you no need to think about how will it work. Like no need to thinking about how you gonna manufacture it. Like you don't need to think those things very deeply, because like this is a conceptual design, and you have to think. You have to mostly focus on the purpose and the functionality. It can be like you are doing this for your university project, it can be for your client, it is for your company. Likewise, mostly you have to focus on your purpose and the functionality. And so at the end of the day, like you will have it can be a normal a pencil sketch, or it can be a 2D picture designed by a Photoshop or something, a Canva or something like that. And again, for the like in the industrial way, like we are using Blender like software to get a 3D model to get an idea about the conceptual design. So after the conceptual design, we have to talk about the mechanical design, but I am focusing basically on the mechanical designing part. So I will cover the electronic and software part now, and I will move to the mechanical designing part. So basically, in the electronic and software parts, I think you already know these things. Like in the electronic and software parts, all the batteries, PCBs, all the MATLAB, ROS, everything will be there inside the electronic and software parts. I'm not going to talk deeply into this. And as for the mechanical design, yeah, that is where the story begins. And yeah, in the when you are going to do a mechanical design, it is not like the conceptual design. You have to like think a robotic arm, and it has it can be a one part, or it can be many parts. Most probably, it can be many parts. So those parts can be manufactured from Uh, different kind of materials, and those different kind of material can have different kind of manufacturing methods. So you have to think about these things before you do the 3D modeling. Like I will do an example at the end. And yeah, when you are doing a mechanical design, you always have to think about what are the materials, how you're gonna do it. Likewise, then you have to do some calculations for then in inverse kinetics when you are talking about robotics and other with the movements and work-based calculation. And you have to think about which is you are not manufacturing also, like gears, belts, screws that you are gonna you have to connect with your manufacturing parts. So you have to think about these things as well, like because you are going to assemble at the last. So again, you have to think about motors and all the actuators. And in the mechanical design, you have to think about the electronic components like sensors as well, because you're gonna attach them into your the product, because you need to think that as well in the mechanical design. Like you have to think from pure mechanical into the whole design when you're gonna do the mechanical design. So then you can get the after thinking about all these things, you can get an final 3D model. So when you're talking about 3D modeling, there are some important factors that I have come up with. Like you have to always think about what are the manufacturing methods that you have available. Like think about like when you are going to create a product and it has so many parts, and think that every part like every part has so many different manufacturing methods, like it will cost you money, so it is not going to work. So you have to think of minimum manufacturing methods, so then it can save you money. Like guys, you have to think those things when you are when you are modeling parts. Otherwise it will be difficult and it will give an headache. So like guys, other things are will be like available materials, and you have to always think of the budget and how to place your components, how to fix a board and thing like this. Like when you're going to insert the bolts, like you cannot put your hand or put your you even can't put the balls into the hole because of the design. So you have to think these things before you gonna design like it. Otherwise, you won't be able to assemble your final 3D model. So other questions will be like, can it withstand the force? You have to do some analysis and calculation part. Like, will it really move? Like, is that part available? Like, can we get in Sri Lanka? Then do you have to go to another country? Like, guys, you have I'm talking like the thinking process when you are doing the 3D modeling. So as for the 3D modeling, I told you that for the conceptual design, we are using the Blender softwares like Blender or something like that. And as for the 3D modeling, when you are doing the manufacture, like the mechanical design, the what is the main difference between the conceptual design and the mechanical design will be the mechanical design can manufacture, and the conceptual design can or cannot be manufactured. So basically, in the 3D modeling, in the mechanical design, we are using mechanical related 3D modeling softwares like SolidWorks and Fusion 360, Autodesk Inventor, and Onshape basically. And as for the simulations, we use Abacus, SimScale, and this likewise softwares. And as for the industry and in the university, Solidus is the like most popular software. But in this session, I'm going to talk about Onshape because I told you that the most popular one is the SolidWorks. But when we talk about SolidWorks, it is a really bulky and a very big and a very complex software, and you need to have a good PC and like guys, it is like kind of difficult to handle. But when we talk about Onshape, it is a simple website. It is a really simple website, and you can handle it very easily, and you can learn very easily, and you can make a simple 3D model very easily without going through so many hazards. So that is why I'm talking about Onshape, and like it has so many features like cloud-based collaboration, parametric and feature-based design, assemble and motion analysis, and integration with simulation and so many add-on features. Like as there are so many features in the Onshape, like it is giving those features by a simply website. Like it is really amazing when we compare it with the SolidWorks. So that is, I think, this is the 3D modeling software I within like Onshape will come to the SolidWorks level. I think it will come at some point. I think that is the future, and that is why we are going to talk about Onshape. So I have up to now I have done some like thinking process and what you have to do when you are doing like manufacturing something, and I'm going to do a small example. Let me stop screen share and yeah. Can you see my screen now? Right again.
Yes, we can see.
Yeah, okay. Right now, like this is a robot arm that developed by Onshape itself, and I'm going to explain something about this doing a small example. So the manufacturing method is mentioned in there like the laser cutter and 3D printer, and 3D printing is mentioned, then it is optional. Like it is because this robot arm can be manufactured without 3D print, and basically we can manufacture this only using the laser cutting manufacturing method. That is why it is mentioned the 3D printing is optional. I will explain again. I think you can see my design. This is the final design of the robotic arm, and as you can see, every bolt is there, and every gears and the electronic components. You can see inside electronic components and the batteries. Everything is there because after assemble everything, this is what it looks like. You have to 3D model up to that level. This is like industrial, like if you go to like industrial level, the wires will be also there in the 3D model. That is the final 3D model will be look like. So that is I told you to give you an idea how you can handle this. And as for the now I'm going to explain this component, and I'm going to talk about how to manufacture this component. Okay, basically, let's think this is a small robotic arm. Okay, let's think this is a small robotic arm. So basically, it is mentioned that manufacturing methods will be the laser cutting and 3D printing. So normally, we are using so you can see this whole part is basically three parts, one two three. Think this is small one, so you can basically manufacture this using a plastic material or a acrylic plates. So I think you know about acrylic plates. So this is a acrylic plate. This is in between plastic and a glass. It is a glass look material, and you can cut that material using a laser cut. So basically, in this scenario, they have used laser cutting to cut these. You can use laser cut to cut those acrylic plates, and you can assemble it like this. But if you're gonna use 3D printing, okay, if you're gonna use laser cutting, you cannot use plastic because plastic cannot be cut from laser cutting. Okay, then think about you are going to use the 3D printing to manufacture this. Then you cannot use acrylic material to 3D print, but you can use plastic material to 3D print. But this whole design will be different. Like you don't need to have these bolts. Okay, because like in the acrylic page you cannot bend it, or you cannot get this bend from laser cutting and the acrylic plates. That is why they use some bolts to connect it there. But if you're going to use the 3D printing, like you don't need to have these connecting bolts. You can simply get this model, and you can print it. So that is the difference between using different materials and different manufacturing methods. That is why I mentioned it. Then again, think this is, I told you that this is a small robotic arm. Think this is again a very large robotic arm. Then you cannot use either plastic or either acrylic paint to manufacture this. You have to go to metals. Then most probably for the prototyping, prototyping, and for the last one also, we gonna use the most probably sheet metals. So sheet metals manufacturing will be also again gonna differ in a different method. Like you can cut sheet metals up to some level, and you can use a bend machine to get this bend. Likewise, with the material and with the forces, with the size, the material will be different and the manufacturing methods will be different. So as for the today, I will talk about how to manufacture this small part, and I will 3D model it, and tell you how to manufacture it. So basically, let me go to a new one. And as you guys see, this is the workspace on shape, and you can click your right click button, and you can rotate this like this, and you can see X, Y, Z axis. But normally, we have to start from a sketch. Okay, you have to. Now I'm going to create this small part, and you have to start from this sketch. The sketch is like this. Okay, this is a basic sketch of this small 3D part. Okay, now I am going to create it, and we have to. You can sketch in it. Sketch that part in the right plane or front plane or the top plane, but you can use any of it, but we are using this top plate because that is where the xy is perpendicular. That is where the xy is perpendicular, because like when you give this to a laser cutting machine, uh, this xy is important. Like if you use this plane, this is Z and Y. Okay. Then, but the laser cutting machine is X and Y axis. So there will be a problem. Like we can fix it in the machine, but it is easy to use this XY in the first hand, because it will be easy for you to give to the manufacturer to manufacture. So basically, you can select this top plane and create a new sketch. And I'm going to create something like this. Yeah, this is a no, this is a normal size, and you can give dimension from this. And when you are giving dimension, make sure to give don't give like small fraction numbers, because like it will when you are if you use laser cutting or like CNC methods, you can go up to like 0.1 0.1 accuracy, but it is difficult for you to assemble when like think you want to create a new way. After you assemble the product, you want to add a new thing, then it will be difficult to add a new thing, because there are so many fractions in the decimal, like you cannot rotate perfectly. Like guys, there will be so many problems if you use so many fractions. That is why like you can use simply 70 like this, the full number. It will be easy for you to handle when you use full numbers. That is why I am using this kind of number, and I'm going to 55, and this is 17, and this is also 70. Then you can use this extrude to extrude this one. As you can see, think again. Okay, I'm talking about the thinking process. Think you are gonna use the acrylic material to laser cut. So there will be, think you want to get the thickness of 1.2. You want to get the thickness of 1.2, but the problem is there is no 1.2 thickness acrylic plate in the market. That is the problem. So you have to think that part also. Like there will be only standard size 1 millimeter, 2 millimeter, 3 millimeter, up to 10 millimeter. Likewise, there will be standard size. So you have to use one of the standard sizes. Okay, otherwise you cannot give the manufacturer to laser cut this. You cannot manufacture it, because there is no acrylic plate in that size. Okay, so you have to think like this, and there is 2 millimeter acrylic plate thickness, so I am going to use 2. And yeah, again, if you want to get an 1.2 millimeter thickness plate, then you can use another manufacturing method. Like you can go to basically 3D printing, then you can get any kind of thickness, 1.2, 1.22, 1.23. Likewise, you can get anything. But if you are going to use the material, the acrylic, and the manufacturing with the laser cutting, you can't do that. Likewise, you have to think that manufacturing process while you are 3D modeling. Uh, so this is the, I think this is the 3D model, and let's think you go now. I have completed the 3D modeling part, and I want to manufacture it. This is the last part. Then first you have to do is, if you use laser cutting, you can't uh, get get the link and give this to the laser cutting operator. You cannot do that. You have to export this file into some other file. Normally, when in the laser cutting machines, we are using DXF file format, and you can do it using this. You can see it here. When if you right click in the 3D model, you will get this export as DXF DWG. Then go to that one, and this is you can select the DXF format, and you can get the export button, and you will have the DXF file. Then you can give that DXF file to the laser cutting operator, and you have to give the acrylic plate also. Then he will cut it and give you the manufactured part. The other one is when you want to now this the next scenario is you want to 3D print this one. Okay, you have to 3D print this one, and then DXF file is not gonna work. Okay, in 3D printing you have to use STL format. Again, you have to right click, then go to export. Then you can use the format STL file format. Okay, STL file format. There are some like you can generate it as a text and binary. Likewise, you can use this thing. You have to select your like the millimeter, meter. These are very important things. Okay, if you give meters, like it will cut in the meters. Okay, if you give millimeters, it will cut in millimeters. Likewise, you have to always think about these things before manufacturing. Okay, so you have to think resolutions. Resolutions means okay. I will talk about later resolutions. Options download. Likewise, you can do some. Uh, you have to select some options from this one. Yeah, so this will be the final part of the like you are 3D modeling while thinking how to manufacture it, and then you can give it to a 3D printer or like laser cutter. Again, and I forgot to mention something. When you like when you manufacture something like as you can see in this robot design also, most of the edges are filleted. See, this is a fillet and this is a fillet. Likewise, most of the edges are fillet because when we are doing a design, when we are designing something like this, we don't use these kind of edges. Okay, we always have to use these fillets. Get the final product. That is the right method because when you're gonna assemble something, when you're gonna assemble this part, these edges can be difficult to like it will be like there will be some constraint when you gonna connect those edges, and the other reason will be like you can get some like small aesthetic look, and the most important thing is like when you're doing work with like when you're gonna assemble these things, uh, it won't happen with the plastic, but think about this is a metal one. Then sharp edges can cause you harm. Okay, there like guys, there are some reason we are using these filleted edges, and it will be like benefit us in so many ways. That is why we use fillets. And like when we like 3D printing, uh, and like we can this is two parts, but if you're gonna print this part as one, you can have a fillet in there also because like it will reduce the corner stresses. Likewise, there are so many good things when you create fillets in your design. So yeah, that's all I think because I first part like I covered how to think the manufacturing, and yeah, this is how you can 3D model while thinking manufacturing, and that are the most popular format that we are used in laser cutting and the 3D 3D printing, which is DXF and the STL file, and I have told you how to export it as well. Yeah, that's all for today, and thank you. Over to you, Nima.